Feeling thirsty for knowledge? Hackers on the Rocks is the podcast that mixes refreshing conversation with potent cybersecurity insights. Serving up these insights with a twist, we pair a different software vulnerability with a refreshing cocktail recipe each episode. All right, hello world and greetings all around. We are honored to have Slava Moskvin on our show today. He has been very active in the vulnerability research space, recently having some tremendous accomplishments on the ZDI circuit. Slava, as is our custom here, we start with an icebreaker. What are we drinking today?
Hey, Evan. Today I'm drinking Radler, the essentially beer mixed with lemon juice, really popular here in Germany. It still tastes like a beer, but it's really refreshing.
Yeah, I have. So you have a pre-made Radler, and I have some German beer here, some Benedictine, and I don't know if I pronounced that correctly, but Benedictiner. Is that right?
Yeah, probably Benedictine.
And some lime, and I noticed immediately super fuzzy at the top, and now it has since gone down. But please give us a toast from native Berlin.
Oh yeah. Here, the Null references.
Yeah, fair enough. Thank you. Yeah, cheers. That is lemony, and this is a very popular drink in Berlin.
Yeah. In all around Germany, really popular.
And of all the drinks we could be drinking, what did you end up choosing, or why did you end up choosing the Radler?
I didn't want to pick anything strong, so Radler is pretty nice middle ground for me. Not too strong, but still an alcoholic drink. Really refreshing, really nice uh, for a good conversation.
Yeah, well, let's have that conversation. So while we're drinking down our Radlers, why don't you tell the audience a little bit about yourself, how you got in the research community?
Uh, yeah, I've been doing this thing for, or I should say, information security in this or that area for about 14 years now. I started on a job that was pretty lame, just mostly documentation stuff on installing antiviruses. Then I switched to infrastructure pen testing, and then to reverse engineering, mostly in IoT space. But of course, Linux and Windows software here and there. And yeah, I've been doing reverse engineering for 4 or 5 years exclusively. And then I switched to automotive space, where I'm working right now as a senior automotive pen tester at Deconium.
That is super fascinating. I think we've had a couple of requests from our listeners to understand a little bit more about the automotive space in general. So I know that's not specifically today's topic, but in general, that is a fascinating space to be in, and I'm super happy for you that you get to poke around at what will be, a future computer on wheels, essentially.
Oh, it's already computer on wheels.
Yeah. This episode is brought to us by IOActive, a trusted partner for Global 1000 enterprises. IOActive provides research-fueled security services across all industries. Its cutting-edge security teams provide highly specialized technical and programmatic cybersecurity services, including full-stack penetration testing, program efficacy assessments, and hardware hacking. IOActive brings a unique attacker's perspective to every engagement to maximize cybersecurity investments and improve the security posture and operational resiliency of its clients. All right, this next segment we call the distillery, where we learn about a vulnerability class. Slava, what are we here to talk about today?
Today we are talking about null dereferences.
Yeah, and so typically when we start, we talk about the terminology of the bug class, and so we've got 3 words, right? Not commonly used by anyone that isn't in programming or familiar with programming concepts. So when we talk about null pointer dereferences, maybe let's start with the middle term. So can you start by sharing with our audience what is a pointer?
Yeah, sure, even. So pointer, like very simple concept. So in computers we have memory. We need a way to address it. So a pointer is essentially a variable that points to a uh, certain memory space, right? So it's basically like a page number in a book.
Got it. Okay, so if I'm understanding correctly, right, I've got a block, or I've got a location in memory, and what it's really doing is it's pointing to another location in memory that could have maybe a variable length. Is that correct? And so it's a pointer is just a good way of being able to keep track of where all the data is. Is that about right?
Yes, exactly. Because of course, when you're programming a piece of software, you typically have a lot of data that you need to take care of. And to be able to manipulate this data, you need to know where it's located. And pointers, they allow you to do that.
All right, so I like this. I've got pointers to pages in a book. So if I need to go to a particular topic, I can reference where I can reference up my pointers where I'm going in program, and so that's super helpful. And so when we talk about null pointer dereferencing, maybe now let's talk about what is dereferencing.
Yeah, so pointer, it's essentially like a reference. Like if we sticking to an analogy with a book, then the referencing would be, let's say I have a pointer that points to page 100. And the referencing would be opening the book on this page and reading or writing something on that page. So the reference essentially is using that pointer to read or write to the memory that the pointer points to.
Got it. And that's important because I can change a pointer as well. Is that right? So when I'm dereferencing it, I'm not changing. I'm not saying this time now go to page 120. I'm still saying page 100 is what we're looking at, and go get the data or change the data at page 100. Is that right?
Uh, yeah, so for example, in a book, you can have chapter about something. Like in a program, you can have array or list or any other data structure. And instead of using like a new pointer every time, you can say, okay, this chapter starts at page 100, and we need something that is on offset 5 from the start of this page. And you can just add 5 to 100, and you end up with page number 105. This pointer arithmetic is extremely common, especially in low-level software.
Got it. I'm sure we'll get to that in a moment. I guess last, for setting up for our audience, what is a null pointer? And yeah, and then we'll get to the dereferencing of them.
Yeah, so null is obviously 0, and null pointer it's just a pointer that points to address 0. And I guess we'll talk in a bit why address 0 is a little bit special.
Got it. Okay. And so the difference between a pointer and a null pointer are the same thing. It's just in one instance, using your example, a pointer, a regular pointer is pointing to a page number, 100, 105, 120, and a null pointer is a special pointer that's not really pointing to any of the pages.
Yeah, exactly. I would say that pointer that it can point to anything. I mean, like a programmer, you can do anything you want with it. You can put it like 100, 0 or 1000 there. You can do it, but 0 in this case has some special meaning. That's why sometimes, especially when we're discussing vulnerabilities, we're talking about null pointers.
Yeah. Well, let's get to it then. So I guess you're here to talk about null pointer dereferencing. So what what is a null pointer dereference?
Uh, yeah, so we talk about that we need to the reference pointer if you want to read to the memory or write to the memory. And yeah, this is an absolutely normal operation. But sometimes when there is a, let's say, uh, special condition, and the pointer can be 0. In these circumstances, the program will try to dereference 0 and try to read and write from address 0. And this is, let's say, with 99% of modern computers, it will be an invalid operation, and will be will cause a CPU exception. And most of the time, if it's a user space program, it will crash. If it's kernel, it can be kernel panic.
Okay, got it. And actually, since we have not really covered this in the show yet, so maybe if you can spend a couple of seconds maybe going over that. So there's user space programs and there's kernel space programs. And if I heard you correctly, the an access violation here would cause a user space program to crash, meaning it would just stop running, but the operating system would be fine. And then there's also kernel programs, and those, when you say a kernel panic, what does that mean?
This is an exceptional situation in the kernel. Well, say panic. So obviously, this is something that is not supposed to happen. In most cases, it will cause kernel to crash. So in Windows, it would be blue screen of death. In Linux, it's called kernel panic. Of course, it's possible, at least in Linux, it's possible to configure the system to not immediately crash and reboot. But the default behavior will be kernel panic and crash.
All right, so I think we're kind of starting at the end here a little bit. So in a program where a null pointer dereference is feasible, it sounds like, I think you said 99%, so we'll go with that stat. So 99% of the time, the end result is some kind of a denial of service, right? The system crashes, the software crashes, the whole system has to reboot. Um, I'm assuming at 1%, the 1% of the time, something else may happen. Can we maybe talk about how that could occur?
Yes, of course, it's more like an edge case, or maybe in some older hardware. I can share a case from my practice.
Hmm?
It was an industrial switch from one of really popular vendors of this kind of equipment, and I found a vulnerability that allowed you to essentially to read from address 0. And this, of course, is null pointer dereference. And my expectation was that the switch would crash and reboot. And I came up with a request to trigger this condition. But to my surprise, nothing happened. And actually, I got data in return. And data was just single A. And why was that? Because the address 0 was actually mapped to memory. And the firmware itself was located starting at 0. And it actually started with bytes A and then 0. And because the null reference was via strict copy, it just copied this A to the reply.
Got it. And so at that point, you can now write to those locations as well. And so in the case of your industrial switch, that's firmware modification? Is that correct?
In this concrete scenario, I couldn't write because there was just some special conditions that allowed reading from 0. So essentially, I gained nothing in this case, and it wasn't even a vulnerability because it didn't even cause DOS, just because this piece of hardware was, let's say, special in a way that it mapped 0 to the firmware.
Got it. And you're saying how you're able to trigger these null pointer deref conditions. We've done a lot of episodes to date where the guest tends to talk about how we interact with software. It could be a human, let's say, using a web browser, clicking around, typing things. Maybe it's URL data, or typing into a form, or uploading files, and then we're going to, like, how does the resulting software receive that data, and what does it do with it? Or we've had a couple episodes now on API security, where again you're sending either text or in some cases some binary data. It's improperly handled. But we've never had a really good talk about how an attacker could influence internal code structures like pointers. And so to me, this is really fascinating. Maybe can you elaborate on, like, how someone would go about having a target program change the pointer data? Like, that seems really just out there for me.
Yeah, so I'll say in case of null references, you want to find some special conditions or special situations in the code that would lead to a pointer being a null or a really, really a low value. I would say that actually most of the time it's not a result of manipulation, but of you finding a special case when some structure is not properly initialized. Because, of course, when you're writing code in most of the modern systems, uninitialized objects, they are filled with zeros, right? And when you're able to trigger some sort of condition, when this object is kind of exists, but it's still not initialized, and but you're making the target to use it somehow and to dereference it. And this would lead to null pointer dereference.
So if I'm hearing you, it seems like how we get to a spot where a null pointer dereference can occur, that to me just sounds like an error perhaps by the programmer where they're thinking the pointer is valid. It's, assuming that it's initialized properly, or is that right? Is it really just the bug class exists because of developers either failing to initialize or failing to properly terminate the once a pointer is done being used?
Yes, I would say, at least from my experience, this is the most common reason behind this vulnerability class. So sometimes it's just some special cases when some objects are not properly initialized or there is no check if it was initialized. And sometimes there is like a state machine of a protocol or some other thing. And the state machine could be so complex that it's really hard for a developer to just analytically kind of foresee every case when this other project is used. So sometimes you can kind of, okay, you go to one branch of the state machine and you initialize the object, but partially, maybe you can cause some weird error or something, and then you make that machine execute another condition where it assumes that the object is already in normal state.
Got it. And, okay, so this harkens back to a recent episode we did with Olivia Gallucci talking about time of check, time of use bugs, and her claim was that it's often timed that those particular bugs exist. And it sounds like this is the same concept here, where you're talking about complex software where there's multi-threading environments or race conditioning where multiple programmers, multiple pieces of code are trying to do things, and it's hard to keep track of the state of the pointers, and simply not doing a check is enough to introduce risk into the code base. Does that sound about right?
Yes,
Okay.
exactly. Yeah.
Got it. So maybe then let's go to the solutions then. So if I'm a developer and I'm or a program manager, like how do I ensure that my code does not ship with these kinds of assumptions or failure to check? Before I release a product to market.
Yeah, I would assume that static checkers would do a good job here. Also, of course, in this day and age, we should talk about AI. I think that there are probably AI solutions, or maybe it's already possible to just ask it to try to find condition when some of the objects you're using are not properly initialized. And of course, there is dynamic testing. There is fuzzing, of course, and is also something that really useful to do if you care about security posture of your products. because of course there are all kinds of tests, but fuzzing, especially if you run long fuzz campaigns or run continuously, it helps to uncover edge cases and scenarios that for us as humans hard to just cover analytically.
And then in all three of those cases, then both a debugging situation or a static analysis tool or AI ripping in either of those cases, the what you're looking for then is some kind of a lack of a check, right? If I am not checking to see if the pointer is null before attempting to dereference it, that's a red flag, and we're looking for instances where a pointer is utilized before the check occurs. And is that kind of how you would use those tools?
Yeah, I think it would be useful to check if at least in the whole call stack before pointer utilization there is some kind of check for the pointer being valid. And I would also try to check the whole state machine to see if there are any invalid states of this machine.
One other thing that maybe comes to mind, we've heard this a few times from guests, is modernizing the language. I guess how important is language between, say, because you've mentioned, I've heard you say low level and high level a few times today. So we've got like C and C++, we've got assembly, we've got Rust and Python and Java. And like, can you maybe break down low level versus high level and where memory safety becomes a thing or lacks being a thing?
Yeah, of course. So yeah, we are talking about pointers. It means we want to manipulate basically raw data at some memory addresses. And this is a feature of low-level languages. So of course you can do it in assembly, in C, and you can do it in C++. But already in C++, it would depend on the style of C++ you're using. And so of course, in most situations, you don't need to do it. And in C++, we have like all kinds of smart memory buffers, smart pointers, and so on. And going higher, if you're talking about Java, Python, and those kind of languages, they don't even have any sort of manual memory um, manipulation. So everything is wrapped in objects. So would say that null pointer dereference is impossible in those kind of languages unless you're trying to uncover the vulnerability in the language itself.
Got it. Okay. That I think is fodder for some of the audience members who want to try and find the next generation of bug class. So thank you for giving them a little bit of inspiration there. All right, so we've covered what is a null pointer, dereference, how they exist. I guess how you from the outside can detect these things. Fuzzers and static analysis and whatnot. Maybe we can turn a little bit, if you don't mind, to maybe some real world applicability here. I think conceptually, I'm following you. It seems like programmer uses a pointer without checking it. I, as a researcher, can find that through static analysis or debugging, and use that 99% of the time to crash the target service. Make that interesting for the audience. So, like, I know you do a lot of research in this field already, and as I mentioned at the top of the show, have done some public work. You've done some public work with ZDI. Can you maybe talk about real world implications of a null pointer dereference in actual commerce?
Yeah, sure. So I'm writing a novel fuzzer that I call Net Shredder. The concept behind it is you do network fuzzing, but you also get benefits of coverage. And right now, I'm targeting Linux kernel, and my first subsystem of choice was KSMBD, which is essentially an SMB daemon running inside the Linux kernel. And I managed to find a null reference that you can trigger remotely without any authentication. And that leads to kernel panic. And here we can circle back to something I talked about earlier, that it depends on your system configuration. Because, for example, in Ubuntu desktop, it immediately causes the whole system to reboot. But Ubuntu server, it's configured to not reboot on kernel panic. But still, if you trigger this vulnerability multiple times, you will cause all kernel tasks and all kernel threads to crash, and essentially your system will become unusable, it will hang, which is arguably even worse than reboot.
Got it. Okay. And so in this instance, and we talked about this earlier, so I appreciate the tease, but you have SMB, right?
Yep.
Is that server message block? That's file sharing, right? Essentially
Yep.
printers and whatnot. And so in modern versions of Ubuntu, there's a kernel implementation of this, and because it had a null pointer deref vulnerability somewhere within the code stack, you can now arbitrarily and, like you said, without authentication, essentially aim at a specific Ubuntu server and cause it to go, the whole system to go down, not just the SMB component to it, but the entire computer just turns off.
Yes, yes. Essentially can do it. That's why I would say that null dereferencing is the kernel, they can be more critical.
Yeah, super interesting. Slava, last call. Where can people go to find out more about you, your work, or anything you mentioned today?
Sure. They can go to my Twitter, just search for Slava Moskvin. I also have my personal blog at slavamoskvin.com. And you can give me a follow on LinkedIn, where I go by Vyacheslav Moskvin. But I guess you can just search for Moskvin and you'll find me.
Yeah, Slava Moskvin on Twitter, on LinkedIn, and beyond. Thank you. I really appreciate you sharing your time with us, being here. Looking forward to seeing what you publish next. Cheers.
Thanks, Ivan. Thank you for having me.